I am very excited to be adding ambient sound to my layout, and I'm going to show you how on Ron's Trains and Things right now. Hi, I'm Ron of Ron's Trains and Things. For a long time, I have planned to add ambient sound to certain sections of my layout. My idea was to have sensors in place in specific locations so that when a person walked into a scene, the appropriate sound would be triggered and played as long as they are in the scene, but when they walk out of that area, the sound would then stop. This way you get the immersive feeling of having the sound, the appropriate sound in the scene, but without the chaos of having all of the sounds playing all of the time. The problem was I didn't really know how to do it. Specifically, I didn't know what technology to use to play the sound files. Well, my friends at Jackson Railcar have just come out with a solution to that problem that I'm really excited about. It is the Environmental Sound Module Pro. Now, this board can play any one of 16 preloaded sounds, or you can upload your own sound files to it to customize it to work with your layout however you want. Now, the folks at Jackson Railcar were kind enough to provide me with one of their environmental sound modules for the sake of testing and review, and I'm going to be working with that today, but I'm also going to be building my own sensor trigger system, and I'm going to show you exactly how I do all of that and get it installed on the layout. So, let's head on over to the workbench and get started. This video is brought to you by Midwest Model Railroad. With 15,000 square feet of inventory and one-day shipping, whether in person or online, they are your one-stop model railroad shop. MidwestModelRR.com, link in the description. This is Jackson Railcar's Environmental Sound Module Pro. I will say off the bat that this board promises to make a feature that I have wanted to add to my layout for years really easy. The board features 9 to 24 volt power input via barrel connector or direct wiring, audio output via speaker hookup wires or 1/8 inch stereo audio jack, trigger input via sensor, external contact closure, external control such as Arduino, and an onboard button for testing. It has a connection for a separate lighting sync board, which I'll show you in a moment, and it also has a USB-C jack for personalized customization of sounds, a selector for up to 16 different onboard sounds, and an onboard volume knob. The board comes preloaded with 16 sound files of storm sounds, construction and industrial zones, campfires, rural, farm sounds, and more. This is the company's sync board, which allows you to sync lighting effects with the sounds for scenes like thunder and lightning, fires and campfires, welding scenes, and others. It controls 2 separate banks of up to 4 LEDs each with separate sensitivity control for each bank. I'll be showing you more about these boards together in a subsequent video. By the way, both of these boards and the full line of products from Jackson Railcar are available at Midwest Model Railroad as well as other fine retailers. I'll post a link to these boards near the top of the description below this video. Back to the sound module, you'll need to supply a speaker of up to 5 watts and 8 ohms. I purchased this 2 watt 8 ohm speaker from Amazon. By the way, all of the items that I use in this project will be linked in my Amazon Picks of the Week in the description down below as well if you'd like to check them out. With the speaker hookup wires connected to the friction terminals on the sound module, I used the onboard trigger button to test all of the sounds, and I was quite impressed. But, as you probably know from locomotive sound, small speakers like this always sound better in a baffle box or echo chamber. The enclosure enriches the sound and really helps boost the bass sounds. I built an enclosure out of scraps of 40,000th styrene from my scrap box. The important thing here is to make sure that all the sides are fully sealed. I cut a hole in one side just barely smaller than the diameter of my speaker. This box will be out of sight under the layout, but I sanded all of the corners smooth anyway. I then applied a bead of Beacon 3-in-1 glue to the perimeter of the hole and glued the speaker in place. To hold the speaker in place until the glue dried, I applied a few dots of gel-type CA, then used some accelerator to make it set up quickly. To make sure I had the speaker sealed firmly in place, I applied an additional bead of 3-in-1 glue around the speaker perimeter, gluing the hookup wires to the box as well. Next, it was time for the control system. Jackson Railcar has a sensor board coming in the near future, and I'll tell you more about it when it's available. They currently have this push-button trigger with a volume control if you want to control your sounds that way. For my purposes, however, I want my sounds to be triggered when a person walks into a scene, so I built a control system with an Arduino Nano, an HC-SR04 ultrasonic sensor, and a G3MB-202P solid-state relay. When a person steps in front of the sensor, it triggers the Nano to close the relay. That connection acts as a switch and closes the circuit on the sound module's external closure input, and the sound plays. I programmed mine to keep playing for at least 10 seconds or as long as the person remained in front of the sensor. Now, you can see in this clip that I've already wired and tested this system at this point. I don't want to bore you with watching me wire and code the Arduino, but I have written up a complete description of the components, a wiring scheme, and a sketch for coding this project in a PDF, and it's yours for free to download on my website. I'll link that near the top of the description down below the video as well, and I'll include the Nano, the sensor, and the relay in my Amazon Picks of the Week. I 3D printed mounts for the Arduino Nano and the sensor, which I downloaded from Thingiverse, but you can find similar ones available online if you don't have a 3D printer. If you're enjoying this sound installation and would like to see more model railroad tips, tools, and techniques to help you build a better model railroad, then be sure to subscribe down below and click that little bell icon so you can catch future videos. To keep things neat, I mounted the sound module and all the other components to a scrap of 1/4-inch plywood with number 2 screws and some standoffs that I had also 3D printed. I drilled a small pilot hole for each screw to make it easier to mount. I glued the speaker enclosure to the board with 3-in-1 glue and again added a bead of CA to hold it in place while that glue dried. I reconnected the speaker wires to the sound module. Honestly, my mounting board was slightly small, but I made it work. I screwed the Nano mount to the edge of the board as well as the relay, all with the same screws and standoffs that I had used earlier. The sensor will mount to the fascia on the layout. I then re-ran all of the wiring to make it as neat as possible on the board. I used Wago connectors for all of the off-board connections. The sound module and Arduino require separate power supplies, as the sound module requires between 9 and 24 volts and the Arduino 5 volts. Personally, I run a 12 volt and a 5 volt accessory power bus under my layout, powered by a modified ATX computer power supply. I made a video about how I modified that power supply to run my accessory buses, and I'll link that in the description down below as well. It was here that I learned something important about the Arduino that I hadn't known before. All of the power in and out connections should be wired to the one 5 volt pin on the Arduino. Do not power the Arduino through the VIN or voltage in pin. Likewise, all of the ground connections should be made through the same GND pin on the Arduino. Otherwise, power will be running through the board unnecessarily and can cause problems to the circuitry over time. I used the friction fit connectors on the Nano, but I will probably come back and solder these connections later. I just wanted to get the board installed and working correctly before I made permanent solder connections. I installed a couple short wires from the relay to the contact closure connections on the sound module. The relay serves as a switch, and when closed, the sounds will play. To keep the wires leading to the sensor neat, I slipped them through a piece of 1/8" heat shrink tubing. I didn't actually shrink the tubing as it was doing its job without it, but I certainly could have. I connected power supply wires to the sound module and added Wago connectors so they were ready to connect to my 12 volt power bus on the layout. I then connected my 5 volt bench supply to the Arduino and 12 volt supply to the sound module. It's crucial to keep your positive and ground wires connected to these boards correctly. I tested it once again here at the bench, and all was well. So I took the unit out and screwed it in place under the layout, and hooked up the power supply connections. This is where the magic happened. I intend to add several more of these boards with various sounds around the layout, and a couple of them will incorporate lighting sync boards as well, which I'm very excited to show you. And when those project videos are available, you'll find links to them and other Model Railroad content in the links on your screen. Remember that PDF, my Amazon Picks of the Week, and other valuable links in the description down below, and join me for future installments as I bring you even more great Model Railroad videos, and I'll see you on the next video. 10, Lizzie?